Welcome, everybody. I am Shawn Neal. I'm from Pivotal. I'm a solutions architect with our team here in the field. And
I'm Jason Stevens. I'm a senior software engineer with Microsoft.
So today we're going to talk about .NET application modernization, with a little bit with Azure DevOps and pipelining those things out. But first, we kind of want to talk about how do we approach modernization.
Yeah, so leading into modernization, let's look at kind of what the state of .NET is now. Obviously, .NET Conf was just a few weeks ago. We've had some announcements. .NET Framework has been amazingly successful over time, right? We have it on over 1 billion devices today. Now, in a certain way, though, we're kind of a victim of our own success because when it's on 1 billion devices, it becomes really hard to make changes to that. Even things like security upgrades sometimes create breaking changes because people program around the expected behavior, and so we've got to be really sensitive about that. Now, in the course of developing .NET Framework, we've come up with some new ideas and we've had some learnings and we want to bring those to market. But at the same time, we want to make sure we don't break the existing stuff. And that led to the invention of .NET Core. So we're coming out with this, or have come out with this, this new cross-platform product. We're very excited about it. It has a lot of our latest thinking in it. And that's frankly the direction that we're going to be going in. Is with .NET Core. So kind of right now, we're in this hybrid state where we still have this very mature product with .NET Framework. We have this very exciting new product with .NET Core. And there's kind of some question about what should people be doing as far as looking at their existing investments, their existing portfolio, as they're looking at these two things. So let's look at some key snippets of how these things relate and looking forward to .NET 5. So first off, I hope people are aware Framework 4.8 will be the last version, the last major version of Framework. We're committed to making sure that Framework is supported. The barn is not burning. There's no rush to get out. We will continue to make security and maintenance fixes to 4.8, but that perspective, that product is not going to be developed with new features. All new development for feature-wise is going to be done in Core. All of the APIs, obviously when Core came out, it was new, it was small. In order to bring it to market as soon as possible, we did not have the luxury of building every single API that was exposed in Framework and putting that in Core. But by now, over the course of the last few years, we have been moving the Framework, the APIs from Framework that we're going to move into Core. They're there now. So if you're kind of waiting for some other API that is not in Core today to come, if it's in Framework, I think the plan is for them not to port any new APIs. So Core is a stable product. At this point, we're calling it kind of mature and ready to go. If you're not already taking a look at it, you should. It's part of your modernization perspective. And certainly for new applications, you should be building those in Core. You should not be building new applications in Framework. And in particular, we have .NET Core 3 today. The next major version of .NET Core will be .NET 5. So you notice we skipped 4. That's to avoid Framework kind of confusion, 4.8, so that people that kind of don't understand that it's like a regression. So next major version will be 5, and we're dropping the core word from our branding. So .NET 5 is the next version of .NET Core. There is no direct path from Framework 4.8 to .NET 5, because that's a transition from Framework to Core. So everything new, C#, 8, .NET Standard 2.1, future versions of the standard, all that stuff is going into Core. And so that's kind of what you should be thinking about as you look about kind of modernization. And here's our timetable. So obviously, right where we are right now, 3.0 is out. We're expecting to release a patch or a minor version upgrade to 3.1 next month. And then we're moving into a cycle where every year there will be a release in November of a major upgrade, and every other year will be a long-term support version of that. So 5 will be GA, 3.1 is LTS, or will be when it's released, and then November 2021 will be 6 and will be the next LTS version. So this gives you kind of a sense of where things are coming, how much time you have to plan. Again, be thinking about modernization, that's why we're here. But you don't have to kind of leap out and do it right now. Start with your new app development, start with migrating your core apps, and then be transitioning so that kind of near the end of the timeline you see here, be planning to be off of Framework and onto Core, onto .NET 5 or 6. And with that, I'll turn it over to Shawn.
Thank you.
Yeah.
So as was alluded to, .NET Core, this is the new thing, that's what everybody should be doing new greenfield stuff in. But what if you have applications that you've had around since 2002 that were originally written in .NET 1, right? And you've kind of kept up to date, maybe it's a web forms app or something like that, right? So how do you approach those kind of applications? I mean, clearly you can't throw out your application that's, your core of your business. You have to keep modernizing those, but how do you approach that, right? And so a traditional .NET portfolio can be pretty complex. So you have lots of technologies throughout the years. Maybe it's web forms, MVC, maybe you've got a little bit of some classic ASP in there somewhere with some COM objects from some old application, some WCF. And then how do you move that to a more microservices, modern architecture? And so there's kind of a spectrum, right? So you have applications that you want to say, well, maybe this one, you know what, we're going to divest in. It's not something we want to keep adding additional monetary value to because it doesn't really make us money, but it's there supporting a need. And there's applications that are probably good enough and they serve their business purposes. So kind of the sweet spot here in the middle of kind of legacy lift and shift, maybe you want to containerize them, or maybe you just want to keep them where they're at. And then you have some applications that maybe you're continually investing in, and there's maybe off of like web forms or something else, but they're still making you money, you're still investing in them. And some of those you might want to actually, they're almost cloud ready with some minor modifications, and you can use like Pivotal Application Service to host those. And then maybe you start carving out pieces of that monolith into writing new pieces and microservices in .NET Core and kind of setting yourself up for the future. So I'm going to talk about a little bit a sample application that actually it's called Funny Quotes. So there's like a web forms UI, there's a new .NET Core service for it, and there's also there's 4 different parts to it. So there's the 2 front ends, a core and web forms, and there's a back end like a legacy ASMX SOAP service, and then a kind of more modern one. It's WCF based. And it uses some new technologies from Steeltoe, like config server and Eureka and some other things that we kind of retrofitted into these older applications. But we're going to show off an Azure DevOps pipeline that's kind of consuming this stuff and pushing it to Pivotal Application Service. So the modernization journey for you is, so traditional is kind of like you're on-premise, maybe you have an ops team that's manually deploying things to your IIS servers, and your release cadence is kind of slow, and maybe you have a large monolithic application. Scaling is kind of difficult because there's not just like a CF scale command you can run and scale up. And then you kind of move over to the spectrum of cloud friendly. So at least you externalize configuration from the deployable unit. You maybe have some automation around kind of deploying the application. And then you're talking full cloud data, so 12-factor, microservices, service discovery, all those kinds of cool things, right? And you get a lot of those out of the box with Pivotal Application Service, right? So you kind of, as far as like, hey, it's going to make sure your application's up and healthy, it's port binding, and you get some other things from Steeltoe where Pivotal Application Service doesn't necessarily fit the bill. So you can use config server, you can use some backing services and bind like MySQL and things like that to your applications, and centralized logging. But how do you actually approach your application? So like let's say you have an existing legacy application and you want to decompose that into microservices. So approach that we have at Pivotal that some other really smart people came up with. I did not come up with this, but it was a Swift methodology, right? So it answers the why of modernization. How can you approach your application from a technology agnostic point of view and start to decompose that and figure out what your bounded contexts are? So it's important that you include not only technical people in this discussion, but business people that understand the processes that go around your applications and why they're doing certain things, whether that's why there might be a particular process that's in an Excel sheet that you're not aware of as somewhere as a developer, right? So it's important to understand the context of the business value you're trying to achieve with your modernization efforts. So one of the things we'll start out with was an event storming exercise where you put the architects, developers, and the business owners in the same room and start going through and creating sticky notes of what the actual application does. And that helps you identify your bounded context and what the application is actually trying to do. Start grouping those together, and you start coming up with bounded context of what the application actually does. And then you start once you've identified some of the service candidates, you can start drawing relationships. You can imagine the service candidates are kind of the nodes in the graph, and then the data transfer, the data between, and the message passing is essentially your graphs on your edge, right, between those service contexts. So that helps you identify the data flow through your application and your bounded context. Once you've done that, do a snappy, which is effectively quickly document the outcome. So stories, some UIs, data, things like that that you actually know can concretely start executing on. But there's risks. There's always risks. So one of the risks, and we're going to talk about, slow legacy releases. How do you work and, like if it takes you a month or a year to roll out a release, right? It's difficult to start pulling apart a monolith because you sometimes have to make breaking changes in your monolith to work with maybe a new pulled out microservice. So the ability to quickly roll out new releases on your existing code base as well as your new code base is invaluable. So let's talk about pipelines a little bit.
All right, so in a few minutes, Shawn's going to step you through how we kind of modernized funny quotes using Pivotal Application Service on Azure. And we chose to do this in a pipeline built on Azure DevOps. So I wanted to give kind of a quick overview of the various services available in DevOps in ADO, because it's a lot more than just pipelines, right? So in our boards component, we have everything from Kanban boards, task management features. You can create your own custom objects, custom fields, super flexible, super easy for a whole team to focus on the data objects that are important to them and organize them and keep themselves organized across sprints. Obviously, we've got repos. ADO has built-in kind of Git and TFS support. And obviously, you can, if you choose not to use one of the built-in repos, we'll see in a second, you can connect to a bunch of repos externally to ADO itself. Pipelines we're going to see more of. It's a feature that has been in use internally in Microsoft for years and years and years. We chose to productize that and put it into Azure DevOps as one of the core features. So this is a very mature product that we use internally to do all of our own delivery. Test plans, pretty self-explanatory. As part of any pipeline, of course, you want to make sure that you're dropping those artifacts that Azure DevOps also manages into the appropriate environment with the appropriate controls, run your tests where they need to be run, and use that as part of your criteria for moving between environments. For pipelines in particular, if you click on the kind of the menu that appears in the portal, you can see that within pipelines we can define the pipeline itself and then other kind of top-level objects that you would think of as manipulating inside of a pipeline, like environments, releases, kind of the way your deployment works, your jobs and tasks, all that stuff goes into pipelines. So you kind of, in this section of Azure DevOps, you're going to define how your pipeline is going to not only build your code, but turn that into then build artifacts, how it's going to deploy those into different environments, which are simply collections of Azure resources like VMs, but also might include databases as a service or other supporting artifacts or resources. And then all that kind of gets moved by the pipeline from place to place. That can stay in Azure. Azure DevOps is able to manipulate objects in other clouds. So it can kind of master pipeline all of your various things that you need to get your code moving. Pipelines are defined in YAML. If you're looking at GitHub Actions, they're kind of similar to what you see there. That's no accident. So it's kind of, you can work in the Azure space, you can work in the GitHub space against the GitHub repo. You're kind of using much of the same technology in either place. It's just a question of whether you want to be more Azure focused or more cloud agnostic focused. Both are great. All right.
Cool. So I'm going to show you a pipeline that we put together. Now it's actually kind of two different parts. It's kind of a build pipeline, and then that creates artifacts, and then a deployment pipeline or release. So the typical workflow, local developer, git commit, push to GitHub, or whatever your Git repo is. From there, you got your build pipeline set up, triggered off commit. That produces artifacts, and then those are then CF pushed out to your various environments. And then those are auto-deployed, the way I have it set up, to auto-deploy each release to your development space or environment. And then for each subsequent upper tier environment requires an approval. So somebody who has permissions to say, yep, this should definitely go to UAT or production or whatever it is. So again, kind of digging down a little bit further here. So that, like I said, there's kind of the two, build and release. So the build pipeline is going to do your compiling and packaging. You could there's built-in tasks to do that. I'll get to that a little bit more. Run your static analysis. So you might have some rules set up, maybe your style guide, things like that, enforce via effects cop. Of course, run your unit tests, right? You want some basic validation that your code commit's going to work, right? Everything's good. That's not the only test you're going to run. And then from there, your artifacts are built. So you might have multiple artifacts, multiple websites, depending on if you have kind of a monolithic repo or if you have a repo per application. And there's advantages and disadvantages to each of those depending on where you are in kind of your modernization journey. For example, if you start out with a single GitHub repo that has your one application in it, that's a monolith, trying to extract out a new service from that and putting in a separate repo sounds like a good idea, and it can be. However, if there's tight coupling in some of the things you're doing in refactoring, it can actually slow you down. So don't immediately jump to using a secondary repository until it's actually a good idea and you've proven out that there's actually enough of a facade between the two that you can consistently do that. And then, of course, you always have a database or something on the back end, right? So probably SQL Server or maybe MySQL or something like that. And then you have to manage, upgrading the database, the schema changes, and other things like that. And there's some strategies. I'll talk about that a little bit. And then, of course, you want some smoke tests. So you want to deploy your application, validate it as actually running and working with configuration in the environment properly. So in this example, remember, I have essentially two backend services and two different front ends. Essentially, I'm basically using the built-in publish profile to Visual Studio. So I'm using the Visual Studio task that's available in the build pipelines and providing some additional arguments on the command line. So I'm basically using a publish profile, and then I have in each of the CS projects basically a artifact staging directory property that gets set, so I'm able to effectively run this against the solution, and it'll compile the .NET Core and the web forms, all the applications, and produce a deployable unit that I can then deploy using CF push or the built-in mechanisms that are in Azure DevOps. So the kind of interesting part to that is that the .NET Core app, I'm pushing to Linux, but I'm building on Windows. So, of course, run static analysis, run your unit tests, right? You gotta have those, make sure they're working. Quick, unit tests should be quick, right? Isolated. Once those are produced and you have your artifacts, you have a secondary release pipeline. So the release pipeline effectively is triggered off of artifacts getting published. So in this case here, you can see I have effectively 3 different environment stages. And those are, in this case, different spaces within the same foundation. They could be different foundations. So you might have a more complex, separate production foundation from maybe your dev and stage. But effectively, goes to dev. It runs some smoke tests against that deployed application, as well as any of the database migrations and things like that. From there, it requires somebody to click approve and approve rolling out that change. So you might have changes that you aren't ready to roll out to the public yet. So the push apps piece of this, right? So you might have, I used a task group, so there's the ability to kind of reuse tasks in Azure DevOps. And so what I did here was effectively, I created a task group that installs the CF CLI, and then there's a built-in, and I'm using all off-the-shelf marketplace tasks for this. I didn't have to rewrite this from scratch. Effectively, you just put in your credentials in a secret store in Azure DevOps, give it the FQDN of your endpoint for CF, and then I just effectively, all you have to do is there's this environment variable here that allows me to have a different public-facing FQDN for each of the environments. So it's just dev dash whatever the app name is. So for production, I just leave it blank. For staging, I might have staging. And that allows me not to have to reset all those properties for every single one of those stages that we saw here. So I can reuse those same set of tasks over and over again. Database migrations are always a bit troublesome, and there's not a one perfect solution. So it really depends upon your scenario, right? If you're releasing very frequently and you have developers who are aware of how to make changes to a database in a backwards compatible manner. So for example, If you're renaming a column or you're deleting a column, you're making incompatible changes with the current code base. So to make this work properly, a strategy is to make forward compatible changes, like additive changes. So for example, let's say I actually did want to change like a data type of a column. You might go through a release of your application where you add a new column with a new data type, it moves everything over, you deploy the new code that can take advantage of that. Then you come back later, and after the application has been deployed and running on this new data type, you can, in a subsequent release, remove that column. But it requires multiple step deployments, and it also really requires you to be able to deploy your application pretty quickly so you don't have branches and other things hanging around for a long time. The other alternative, which is we're probably all more familiar with, is having downtime when you have to do database migrations. Oh, I also want to point out here, like the way I did this in this case was that instead of like running it directly from the worker node, it's effectively just running using the built-in CLI task, which then just runs run task. And a run task is the ability to effectively just say, hey, I want to run this CLI command against this deployed code. And what it does is, in this case, it actually just runs this PowerShell script that then effectively just runs migrate.exe. And so it's running and using the bindings from the VCAP services for your application and just running the migrations that are already deployed along with that application. So it makes it so you don't have to configure things twice. You have one deployable unit. Just kind of a quick, easy way to get that working. And then, of course, you want to run some smoke tests against your application, like, hey, did the database actually work? Can the application talk to the database? And you want to validate all that stuff, right? You can't just assume that your unit tests are going to work in a real environment. And so you use like maybe WebDriver tests or something like that. And that kind of fits in the test pyramid where you have your base unit tests. Maybe you have some acceptance tests that are actually hitting like running API tests and things like that against a deployed service. And then maybe some like top level smoke tests that are kind of like, hey, as a user through the browser, I can log in and I can do this critical business action and things like that. So the build pipeline summary effectively is, yeah, compile, package all the resources and all the different websites together, right? Using kind of the built-in Azure DevOps tasks, and then run static analysis, your unit tests. Once you have the artifacts, then it falls into the build pipeline or the release pipeline. The release pipeline then does the actual deployments to each of the environments, has the approvals, and also runs kind of the high-level tests against the deployed code. And of course, database migrations require care. Just remember that database migrations are probably your biggest single point of pain. And while I say that you can do forwards compatible changes, it requires discipline and testing in your development organization to be able to do something like that, and the ability to release quickly, because you don't want to have months and months of changes in your database migrations and then try to do them without downtime. So, thank you. Any questions?
Those pipelines you have shown are already integrated with Jenkins or from two.
What was the question? Sorry.
Pipelines you have mentioned earlier with Azure.
Mm-hmm.
Those are already integrated with Jenkins, or we have to add extra Jenkins on top of that.
So this is purely like Azure DevOps pipelines. You could do something similar in Jenkins. So the question was, if I got this right, the question was, does this work with Jenkins or?
Jenkins already integrated with that or not?
No. This was not set up with, so yeah, this wasn't integrated with Jenkins or anything with Jenkins. Effectively, Azure DevOps was doing both parts, the build, the compile, producing the artifacts, and then separately, the release part. So Azure DevOps will do the whole thing from end to end. You could use Jenkins if you wanted to. We definitely have customers that use Jenkins for all kinds of things. Sure.
So you have the build pipeline and the release pipeline, but lots of other productions have a pipeline to put whatever you need. So what's the consideration behind the design?
So the question was, why is there two parts to it, and is it extendable? Why is there a release pipeline and a build pipeline?
Yeah, there are two separate entries, right?
Mm-hmm.
Build and release.
Yes.
But actually, I can do release stuff in the build pipeline.
Yes. Okay, that's a good point. So why is there two separate? Why is there a build pipeline and a release pipeline? So his point was, I can do everything in the build pipeline. You absolutely can, because effectively you can run a shell, run it out to the command line. The reason I did it through the release pipeline is because there's some built-in functionality for approvals for that part, as well as then I have a distinct segregation between like the build part. I might have an organization where I have like a development team that's responsible for the build pipeline, and maybe in my organization it's another team that does the releases. And so they have kind of a segregation piece there. And it kind of just makes you a nice workflow. But you could totally just put everything all in the build pipeline if it makes sense for your organization. I've definitely seen that. Hello.
So are the Azure pipelines codifiable? Like, is it possible to configure them as code and promote changes of pipelines?
Yeah,
Yes.
so the question was, are the pipelines codifiable? Is there like a YAML document which describes? Did you want to answer that one?
Yeah, sure. So in fact, the pipelines are defined as YAML, and one of the first things that happens, in fact, the first thing that happens when you create a new pipeline in Azure DevOps is you have to associate that pipeline with a repo. And the initial commit that happens automatically is a very simple pipeline, a YAML document that defines basically an empty pipeline, and then every change to the pipeline after that is under regular source control.
Like there it is.
What scripting language do you support?
Scripting language in YAML. So YAML is the YAML is defining the tasks, right? And so you can, anything that you can define in a task. So we saw, for example, using the CF CLI, anything that you could use in a regular scripting environment, you can define a task for it.
Bosh or PowerShell scripting in there as well?
Yeah, you can use effectively, so like in this case, I just have like a Visual Studio. There's tons of tasks, so like a Bash shell, there's PowerShell, basically all kinds of different task runners that you can use for whatever shell scripting or whatever you want to do. For this one, like for example, it's just literally running Visual Studio and then like essentially MS Build to produce the 4 different artifacts that I'm publishing. Which is kind of a pain to get the right parameters all for the web publish profile to work properly to produce an actual file system across .NET Core and .NET Framework.
If you're using Cloud Foundry, one of the things that you'll find in Azure is that in a lot of places we have first-class support for the Cloud Foundry and Bosh CLIs. So here there's a regular task already kind of supported in ADO for running anything you can do from the CF CLI. If you go into the Azure Cloud Shell, for example, through the portal, the CF CLI is present in the container that's being run there. So you can simply log in through the portal, pull up a shell, and use the CF CLI directly to connect to your foundation. Same thing here in ADO. Other questions?
Cool. All right. Well, thanks everybody.
Yeah.